This question is from page 270 in your book. It's asking us to find the equations of the tangent and the normal lines to the graph. So the first thing we need is the gradient function, and to do that we need to differentiate the equation of the curve. So let's do that right now. Now remember that you're going to take this power, put it to the front, so that's 2x, and then you're going to take the power and minus 1, so that gives us 1. Do the same thing here. Imagine this is a power of 1, so that just becomes 4, and then subtract that 1 becomes 0, so it's just that. That is your gradient function. What that means is that I can substitute in any point on the curve into the gradient function, and it will give me the gradient of the tangent line at that point. So now we need the equation of the tangent at this particular point, at the point 3, negative 3. So we just need to substitute in x is equal to 3 to find the gradient at that given point. Therefore, if x is equal to 3, the gradient at this particular point is going to be 2. That's because this is 6 minus 4 is equal to 2. So that's our gradient. But to find the equation of the line, I need the gradient plus a point, and our point is 3, negative 3. And I can use this form of an equation of a line. It's going to be y minus y1 is equal to m, that's your gradient, times x minus x1. So now I substitute in this x here and this y here. So now I've got y minus negative 3 is equal to m, that's 2, x minus 3. So that's y plus 3 is equal to 2x minus 6. Subtract 3 from both sides, y is equal to 2x minus 9. So that is the equation of the tangent to the curve at the point 3, negative 3. Now when we sketch this, that'll become a bit clearer. But now we need to find the equation of the normal line. So it's important to remember that that is going to be perpendicular to the tangent line. So what do you know about gradients of perpendicular lines? If the gradient of the tangent line is equal to 2, then the gradient of the normal line, which is perpendicular, is going to be the negative inverse. So now we have a gradient of negative 1/2, but it still goes through the same point. So we can still use that same equation. Y minus y1 is equal to m times x minus x1. So the same thing, I'm going to take this x and put it into there, and this y and put it into there, and I'm going to take the gradient and put it into there. So now I have y minus negative 3 is equal to negative 1/2 x minus 3. So y plus 3 is equal to negative x over 2 plus 3 over 2. So I'm going to subtract 3 from both sides. I'm going to make the 3 equal to 6 over 2, and that will help me out here. So now I have y is equal to negative x on 2 plus 3 on 2, subtract 6 on 2, because that was my 3 here. So now I end up with the equation of negative x on 2 minus 3 on 2, and that is the equation of the normal to the point 3, negative 3. And the next part is we need to sketch the graph of those, and then you'll understand a little bit better about what that all looks like. Now here I've drawn my axis and labeled them, and it's very important that you do label it. And I'm going to start by graphing the curve. Okay, so x squared minus 4x. Now I know that it goes through negative 3, 3. I've already been told that. And I know that it goes through 0, 0, because if x is 0, y is also 0. You can just put that into the equation, 0, 0, it's going to be 0. But what other characteristics can I find out to help me graph this? Well, remember, if you look at a parabola in this form, you know that the vertex is given by negative b over 2a. So in this case, my a is going to be 1, and my b is negative 4. That's here. So therefore, my vertex is going to be equal to 4 over 2, which is equal to 2. That's the x value, okay? Now, what's the y value when x is equal to 2? Well, I substitute back in the 2 there. So it's 4 minus 4 times 2 is 8. That's equal to negative 4. So that helps me graph another point. So if I go to 2, negative 4, it's going to go through there. Okay, so that's going to be the vertex here. I'll just put a V to give you vertex. So where is it going to cross the x-axis? So let's have a look at another point where we have y is equal to 0. So looking at x squared minus 4x, I want to find another line, and let's put that equal to 0. So x squared is equal to 4x, therefore x is equal to 4. So that must be here. So now I've got enough information to do a reasonable sketch here. So going through there, and that's a reasonable sketch of my parabola. I need to sketch the tangent line, which is this equation here, 2x minus 9. So we know that it's got to go through this point here. So I'm going to make this red. But what else can I find out? Well, if x is equal to 0, if I put 0 there, then y must be equal to negative 9. Okay, so that means when x is 0, y is equal to negative 9, somewhere down here. And what about if y is 0? So what about if 2x minus 9 is equal to 0? Well, that will tell me that it's going to be 4.5. So it's going to cross about here. So I can probably do a reasonable job of this now, of my sketch of my tangent. Actually, that was pretty crap. Let's try that again. So say this is 4.5 here and 9 down here. I'm going to go through there like that. Alright, that just leaves me now with the normal, which is this one. So what would happen if x is equal to 0 with this line? Well, if x is equal to 0, y is going to be negative 1.5, so about there. So, and remember, it goes through here. So that's going to give me a pretty rough guess that that's going to be something like this. Okay, and that's my normal line, and it goes through here. I know that because I could work that out if I said y is equal to 0. Okay, and now that's pretty bad line. So let me make that better. So like that, and that's good enough for a sketch, but if you've got a ruler it would be even better. So in part B, I'm going to show you how to do all of that using your GDC. So look out for part B.